Okay, in this video we're going to look at factoring, and solving equations by factoring. Okay, before we do that, we have to look at something called the zero product principle. Okay, and it's a pretty easy concept once you understand it. If you multiply two factors, a and b, and get 0 for an answer, then a and or b must be 0. Okay, so essentially all that's saying is, if I just choose a number like say 3, and I said 3 times something equals 0, then we know that whatever's in the blank here has to be 0. Okay, if I told you something times 3 equals 0, then we know that that something that we started with, the first number, had to be 0. Because the only way to multiply two numbers and get 0 for an answer is if we know that one of those numbers is 0. Okay, and that's all the zero product principle is that if you multiply two factors, okay, a and b, okay, are factors, and get 0 for an answer, then one or both of those factors must have been 0. Now how that applies to what we're doing is if we took x minus 5 times x plus 2 equals 0, we have to look at this as the same idea as a times b equals 0. Okay, it's that same concept. Except now it's a little more complicated than just saying a is a number like 3. Now we're looking at a as being like x minus 5. Okay, so instead of just multiplying singular numbers together, now we're looking at factors of x minus 5 and x plus 2. But the zero product principle is the same idea, except now we're saying that that factor, x minus 5, could have been equal to 0, or that factor of x plus 2 could have been equal to 0. Well, what minus 5 gives you 0? Well, here you can add 5 to each side to get x equals 5. Or, on the other one, if we subtract 2, we get x equals negative 2. Okay, so there's our solution. X equals 5 or x equals negative 2. And if you were to substitute back in, 5 minus 5 is 0. Okay, so that'd be 0 times 5 plus 2 will give you 7. Does that equal 0? Yes, because 0 times 7 equals 0. On the other one, if you substitute negative 2 in, negative 2 minus 5 will give you negative 7 times negative 2 plus 2 is 0. Does that equal 0? Yes, because 0 equals 0, so that checks. Okay, they both give you 0 for an answer. Okay, in part B, same idea. We have two factors, x plus 7 and x plus 1. We're getting 0 for an answer. Okay, so we're multiplying these two factors and getting 0 for an answer. So one of those factors, either x plus 7 had to be 0 or x plus 1 had to be 0. So on this one, we'll subtract 7 to get x equals negative 7. Or on the other one, we have to subtract 1 to get x equals negative 1. So x equals negative 7 or x equals negative 1 is your solution. And again, you could substitute those in. If you put negative 7 in the first one, we have 0 times, technically negative 6, but it doesn't even matter because we got 0 here because negative 7 plus 7. And then another one, if we put negative 1 into the second factor, negative 1 plus 1 is 0 times anything will give you 0. So they both work. Part C is a little different. Not the way it's set up, but 3x minus 1 times x plus 8. We're multiplying two factors, getting 0 for an answer. So one of those factors, either 3x minus 1 had to be 0, or x plus 8 had to be 0. Well, what's different about this one is that it's not just x minus 1, it's 3x minus 1. Well, the process is still the same. You want to get x equals, so add 1 to each side. So 3x equals 1, and then divide by 3 to get x equals 1/3. And then or, in this one, if you subtract 8, I'll just write it way down here, you get negative 8. Okay, so there's your two solutions. And if you check that one, if you put 1/3 in, 3 times 1/3 will give you 1. Okay, so 3 times 1/3 is 1, minus 1, that's 0, times anything will give you 0. Okay, so that does work. Okay, part D is very similar. Okay, so if you go through and do the steps on that, okay, I'll just put the answers up here quickly for you. Okay, you can pause the video if you need to. Okay, but there's part D. Okay, that's similar to part C. We get -7/2 equals x and x equals -3/5. Okay, part E. Okay, this one we have x times x minus 4. So our two factors are x and x minus 4. Okay, so factors meaning what are you multiplying? We're multiplying x and x minus 4. So those are your two factors that you set equal to 0. X equals 0, and that one's already done. Okay, so 0 is an answer. And then x minus 4 equals 0, so you add 4 to each side, and there's your two solutions. And then in part F, the two factors that we're multiplying together are 3x and 2x minus 7. So each of those factors, set them equal to 0. So 3x equals 0 or 2x minus 7 equals 0. And then when you solve those, if you divide each of these sides by 3, okay, so if you divide by 3, 0 divided by 3 gives you 0. And then in the other one, if you add 7, you have 2x equals 7, and then divide by 2 to get 7/2. Okay, and then the next part, okay, question number 2. So now that we get the zero product principle, okay, we can see that that factored form is relatively easy to solve. Okay, so doing this, okay, doing all this up here, okay, that should be a pretty easy steps to take, okay, once you get into these forms. Okay, but now it would be helpful to know, how do we get the factored form? Okay, so we're going to multiply each of the following, then examine how you may work backwards from the standard form to get the given factored form. Remember, the standard form, you put the largest exponent term first, and then the next largest, then the next largest, and so on. So for a quadratic standard form, that'd be like ax squared plus bx plus c, okay, getting in that form. Linear form would be ax plus b. Okay, so those are standard forms, okay, for linear and quadratic. So if we have the factored form of x times 3x minus 4, that is the factored form. Again, it looks similar to what we had up here. Okay, like x times x minus 4, okay, kind of the same idea. X times 3x minus 4. So if we work backwards, okay, and we actually multiply this together, x times 3x, so using the distributive property. So x times 3x is 3x squared, and then x times -4 is minus 4x. Okay, so that is the standard form that we end up with, and we started with the factored form. Okay, so now the question is, how can we start with the standard form and end up with the factored form? So if we start with 3x squared minus 4x, okay, the idea there is to turn it into the factored form. Say, remember, factored form means what do you multiply together to get your result? So just for example, we know that 2 times 4 gives us 8. Okay, because we multiply 2 times 4 to get 8. So one pair of factors for 8 is 2 and 4. Well, another way to look at that is, if you divide each side by, say, 2 divided by 2, they cancel out. 8 divided by 2 is 4. So one way to look at going backwards, if you're given the factored form, like 2 times 4, one way of working backwards is to divide your 2 times 4 by a common factor, in this case 2. And if you divide each side, okay, that'll give you what you're left with for your standard form. I'm sorry, I should say not what your standard form. That'd be what you're left with for your other factor. Okay, so I probably just totally messed you up there. Okay, but looking at this, if we started with 3x squared minus 4x, we look at what can we multiply together to get that? Well, we know it should be x and 3x minus 4. So if we look at, if we can divide 3x squared and 4x by the same number or variable, okay, then that'll be one of our factors. Just like over here, 2 times 4, if we divide each side by 2. Well, now what we're looking at is, what can you divide each term here by? Well, if we look at 3x squared and 4x, we can divide both of them by an x. And 3 and 4, there's nothing you can divide 3 and 4 by other than 1, but that doesn't help you at all. So if we were to look at, okay, divide each of those terms by x, what are we left with? So you can look at dividing each term by x, or you can look at it as a more common way of looking at it is x times what gives you 3x squared, and then x times what gives you negative 4x. Well, x times 3 gives you 3x. We need x squared though, so there's still an x left in it. So x times 3x is 3x squared. X times what gives you negative 4x is negative 4. And if you were to multiply that back out, you get what you started with. The next one, 2x times x plus 6. Well, here if you distribute the 2x, you get 2x times x is 2x squared. 2x times 6 is positive 12x. Okay, so there's the standard form, 2x squared plus 12x. The way you work backwards on that and write that in factored form would be, can you divide 2x squared and 12x by the same number and or variable? Well, 2 and 12 you can divide by a 2. X squared and x you can divide by x. So there's your greatest common factor of 2x. Now what do you have to multiply that by to get what you started with? Well, 2x times x. Okay, so 2x times x will be 2x squared. And then 2x times what gives you 12x? Well, positive 6. Okay, so there's the factored form and standard form. Okay, the next one, or the next couple, are a little different. Okay, here, when you have x minus 5 times x plus 2, okay, remember this is your, you can use FOIL, first outside, inside, last, or you look at it as multiplying x in the first parentheses by x plus 2, and then distributing the negative 5 to the x plus 2. Okay, so if you do that, x times x will give you the x squared. X times 2 is positive 2x. And then the negative 5 times x is negative 5x. And then negative 5 times 2 is negative 10. Now this is a little more difficult to figure out after you write the standard form. X squared minus 3x minus 10. Okay, given that standard form, it's a little more difficult now to break that apart into its factors. Okay, here, when you look at those 3 terms, okay, notice there's 3 terms now. Okay, the first 2 had 2 terms. Now we have 3 terms. Can you divide each of those terms by the same number and or variable? Well, x squared minus 3x minus 10, you cannot divide each of those terms by the same number or variable. So there's not going to be a number in front of the parentheses like there was in the first 2. Okay, so here, if it factors, okay, if you can write it in factored form, we have to look at where did the x squared come from? Well, the x squared came from originally multiplying x by x, the first terms. So if it factors, we're going to start with x times x to get x squared. And then if we think about where did the negative 3x come from? That came from adding those middle 2 terms together, the 2x and the minus 5x. So if you add the 2x and minus 5x, add those together, gives you negative 3. Well, if you say, well, okay, Martz, I know that if I do negative 4 plus 1, that'll give me negative 3. Okay, but the problem is you could add an infinite number of numbers together, or pairs of numbers together, to get negative 3. Okay, you could add negative 5 and 2. You can add negative 6 and 3. You could add negative 7 and 4. Okay, you can keep on going. The other thing you have to pay attention to, they added to get negative 3x in the middle, but where's the negative 10 come from? That came from multiplying the negative 5 times 2. Okay, so essentially what you have to do is you have to find a pair of numbers that do 2 things. The first thing is they have to add to negative 3x, but they also have to multiply to negative 10. Well, the standard way to figure it out is to look at what multiplies to negative 10 first, because there's going to be less pairs of factors of negative 10 than there are numbers that add to negative 3x, because we're only going to focus on integers. Okay, we're not going to look at fractions like 1/2 times negative 20, okay, or 1/3 times negative 30 or anything like that. We're going to look at the integer factors. So if you think about what multiplies to negative 10, well, negative 1 times 10, or 1 times negative 10, or negative 2 and 5, or positive 2, negative 5. Okay, those are the integer factors of negative 10. Now, do any of those add up to negative 3? Yep, negative 5 plus 2. So if we do a plus 2 and a minus 5, that should work. And you should be able to multiply it back out and get what you started with. So x times x is x squared, okay, which is good. And then you have negative 5x plus 2x. So you have a negative 5x plus 2x will give you negative 3x. And then positive 2 times negative 5 is negative 10. Okay, so that works. Okay, so this is the factored form right here. Okay, these do take a little bit of getting used to. It takes a little practice, okay, but you can get them, okay, if you try. Okay, x plus 8 times x plus 3. If you multiply that through, okay, or distribute that, x times x is x squared. X times 3 is positive 3x. And then you have plus 8x plus 24. So the standard form there is x squared, and then 3x plus 8x. Notice they add their sum to get 11x, and then plus 24. So if you want to work your way backwards, first thing you look at is there a number or variable you can divide into x squared, 11x, and 24? Okay, if there is, then it's going to be a common factor like the first two. If there isn't, then if it factors, it's going to be two sets of parentheses like that. Now, where does the x squared come from? X times x to start the parentheses. And then what numbers multiply to 24 and will add to positive 11? Well, if you list the factors out, you have 1 times 24, the 2's and the 12's, 3 and 8, 4 and 6. 5 doesn't work. Well, 6 will work, 6 times 4, but you already have that here. Okay, and also, you don't want to forget the negatives. To get a positive 24 when you multiply, they could also both be negatives. Now, I'm not going to write them all because, remember, they have to add to get positive 11. If you add two negative numbers together, you're never going to get a positive 11x. So we can ignore the negatives on this one. So do any of these pairs add up to 11? Well, 3 and 8. So a plus 8 and a plus 3. Okay, and again, that's the correct answer. Okay, so in number 3, we want to factor each of the following. So to factor x squared plus 5x, well, can you divide them each by the same number and or variable? Well, x squared and 5x, they both have an x in them. So we can have a common factor of x. And then x times what gives you what you started with? X times x is x squared. And then times positive 5 times x will give you 5x. Okay, so there's the factored form. Part B, 8x squared and 6x, 8 and 6, you can divide them both by a 2. The x squared and x, you can divide them by an x. So there, 2x is your common factor. And then 2x times what will give you 8x squared. Well, 2x times 4 is 8x, but we need 8x squared, so we need another x with the 4. And then 2x times what gives you negative 6? Well, minus 3. Okay, in part C, can you divide each term by the same number or variable? Well, x squared, 5x, and 6, you can't divide them by the same thing, or the same number or variable. So if it factors, be two pair of parentheses, and x times x will give us the x squared. Now, does anything multiply to positive 6 and add to 5? Well, the factors of positive 6 are 1 and 6, 2 and 3, or both negatives. Okay, negative 1, negative 6, and negative 2, negative 3. Now, we know the negatives won't work because they have to add to positive 5. So which of these will add to positive 5? Positive 2, positive 3. Okay, then the last one, part D, x squared minus 4x minus 12. Again, you cannot divide them all by the same number or variable. So if it factors, x times x is x squared. What multiplies to negative 12? That'll add to negative 4. Well, if you go through all the factors, you'll see that negative 6, positive 2. Okay, then the second page. Okay, now we're going to solve quadratic equations by factoring. And what you'll notice is the only difference now is before we had these, the directions said to factor each. Well, that means you make the parentheses, you write the standard form in its factored form now, and you're done. Okay, basically you end once you get the parentheses made. Well, now we're going to solve each of the following by factoring. And we're going to use the zero product principle, okay, again, which was this idea here, that if you multiply two numbers, two factors to get 0 for an answer, then one of those factors had to be 0. Okay, essentially is what we just did in number 1 earlier in the video. Okay, so once we get the factored form, those are easy to solve, setting each factor equal to 0. Okay, so with x squared minus 6x equals 0, again, what you look at is, can we factor that left-hand side? Well, can we divide x squared and 6x by the same number or variable? Yep, we can divide them by x. And then you'd be left with x minus 6. Now we have an equation here, so we're not done. We have equal to 0. So now we're multiplying two factors, x and x minus 6. We're getting 0 for an answer. So one of those factors, either x had to be 0 or x minus 6 had to be 0. So when we solve those, this one's already done. And over here, if you add 6 to each side, you get x equals 6. And you can check those to make sure. Substitute 0 in, that works. Put 6 in, that'd be 36 minus 36. That also gives you 0. Okay, so for the sake of time, I will have you pause the video and I'll put the answers up. So then if you get stuck on one, you can see where you missed it. Okay, but again, the only thing different here is now you're doing both of those steps where you write the factored form and then write the solutions because you have an equation now you're trying to solve. Okay, and I should mention that you have to get equal to 0 first, so you can apply the zero product principle. So B and C are already good because they're equal to 0. D is good, but E and F, notice how they're not equal to 0 yet. So in part E, you need to subtract 7x and add 10. And in part F, you need to subtract 6. Okay, so you get them equal to 0 first. Okay, so I'll put the answers up. Okay, so pause the video. Okay, so there's the solutions for those. Okay, not much for me to say here, except I have a kind of messy writing there. This is an x plus 4 in part C times x plus 5. Okay, so that's a plus 4 right here. So you get negative 4 and negative 5 for your solutions for x. Okay, so that's number 4. Okay, not much for me to say on those. Okay, and then finally question number 6. Okay, we can see that the factored form of an equation may be easier to solve than using the quadratic formula. It depends on what you're given. So solve x squared plus x minus 20 equals 0 by factoring and by applying the quadratic formula. Okay, so this is just so you see you can use either method to solve. You can always use the quadratic formula. Okay, no matter what your numbers are, you can always use quadratic formula. But sometimes the algebra gets trickier, the arithmetic gets trickier. So factoring, if you can factor, is usually the more efficient and faster way to solve quadratic equations. Okay, if the equation factors, or if the expression factors. So if you look at x squared plus x minus 20 equals 0, okay, I want you to use factoring and then use the quadratic formula. Okay, and I'll put the answer up just so you can see. So pause the video, go through and do that. Okay, and here's the answers. Okay, and you notice that we get x equals negative 5 and x equals 4 for both of the methods. But most people would agree that the factoring method, okay, will be a lot more efficient and a lot faster to do. Okay, less apt to make mistakes when you factor. like over here when you have all these negatives floating around.